Alright, hopefully, if you're listening to this, that means you got to Schoology, you figured out the course code, blah, 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 blah. You've picked out the notes video. You have a notes handout in front of you. If you don't have a note handout, you need a note handout. Basically, what this is a resource. I made a video just for the first day, and then we'll go from there. So we're going to do rectangles. So if you're coming from Snowbacks and you don't know who I am, it's going to be weird because now on Tuesday or on Monday, you're going to match a voice to a face. So here's the rectangle. A rectangle, so you guys are going to have to get used to my handwriting too. So is a parallelogram. Alright, so we did parallelograms. There was a little quiz before the final where we started talking about parallelograms with 4 right angles and then it has the following properties. So every one of these numbers is a property. Alright, so we're going to have to explain all of those to you, and hopefully it goes pretty smoothly. Can't take questions, but I think most of you by now, after algebra and all that stuff, should know that all 4 angles are right angles. Alright. Okay. We also know from parallelograms that this is still the same. Opposite sides are equal. Equal and parallel. Another word for equal is congruent. Alright, so I'm writing this down so you guys should be able to keep up. If you can't keep up, make sure you pause the video. Alright, that's always an option for you when we have videos. So if you're confused before the quiz, come back, watch this video again. So then the other thing would be opposite angles. And opposite angles in parallelograms are congruent, and opposite angles are still congruent for rectangles. So really what we're doing is we have that fancy word quadrilateral, and then quadrilateral can be broken down, and some of them are parallelograms, and then inside of parallelograms, well, some of them are rectangles. So it just gets more and more specific each time you go. So consecutive angles. Well, if all 4 of them are all right, consecutive angles are going to be supplementary. Alright? So you need to know that all consecutive angles are supplementary in rectangles. If you remember, we talked about diagonals in parallelograms. Diagonals are bisected. And make sure you know bisected means cut into 2 pieces. Looking ahead a little bit, your homework tonight is going to be all of these. All 6 of these properties we're going to challenge you to know and challenge you to be able to answer questions about them. Okay? Also, in rectangles, so this is a new one for rectangles, but diagonals are also congruent. So that's supposed to say are also congruent. So diagonals are congruent in rectangles. And actually that last one that I just gave you is actually the only thing that's supposed to be new. Okay, so we have all these things about parallelograms you're supposed to know. We probably didn't cover it as well as we're supposed to before the final, but we did talk about them. Right now what I would do is I would make sure I have my note sheet out and keep it out while we do our homework. So there'll be a homework worksheet, and you guys can stay in the classroom and help each other out. So if we go to the next slide here. So example 1, constructions. Right, a rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet and LN is 6.5, find KM. So they gave us two things. They gave us JK is 12 feet. They also gave us that LN is 6.5 feet. Okay, from that, number 2 in my notes says that opposite sides are parallel and congruent. So you should know right now M and L is also 12 feet. Okay, that doesn't really help me find KM, and KM is this green line that I'm looking for. So then I would look for something that talks about diagonals. It says opposite 3, 4, 5. Diagonals bisect each other. So diagonals bisect each other. So in blue here, I have 6.5 from N to L. That would mean that J to N is also going to be 6.5 feet. Okay. That also means that J to L, that whole diagonal, is going to be 13 feet. I already know the answer. Okay. KM is going to also be 13 feet. And the reason for that is number 6 in your notes. Number 6, the number 6 property of rectangle is going to say diagonals of a rectangle are congruent. So I knew if JL had to be 13, and JL is 13 here, then KM has to be 13. So we're just going to use one property to get to the next property to get to the last property, right? Everything's going to work out kind of like this and be very similar to this. It's another one of those things where it's going to be part plus part equals the whole thing, and you got to know what pieces to set equal. Here's one for you. Example 2. Right? Ooh, they're talking about angles. So FGE. F to G to E would be this blue angle. And H to F to E would be this green angle. Okay, and it wants us to find X. If you don't have any ideas, that's a good thing. Alright, so it says diagonals bisect each other. That doesn't quite help me here, because we're talking about angles. All angles are right angles. Okay, so that means this whole thing is a right angle. That doesn't quite help me. I know what's supposed to happen. Alright, so here's what happens. This blue one, okay, and this blue one have to be equal. Because if I drew a black line here, a black triangle, if I colored in this triangle, it is our favorite isosceles triangle. Okay, so that black triangle there has to be isosceles. So if I go back, and this angle has to be equal to this angle. And then if they give me this one as 4x minus 5, and the blue one is 6x minus 5, and this red one is a right angle, that means those two added together, so 6x minus 5 plus 4x minus 5 equals 90 degrees. And then we're combining like terms. So 6x and 4x are like terms, so there's 10x. Minus 5 is going to be minus 10 equals 90. I add 10 to both sides, and 10x equals 100. Divide by 10, divide by 10, x equals 10. Good news is we figured out that problem. Even better news is that one's not on any test or quiz. And I'm glad because it took me, well, you heard me. I didn't talk for like 20 seconds, so I figured out how to do that one. So that's a really good problem. If you understand those blue angles are congruent because it's an isosceles triangle, perfect. So that's not something you need to know. And then we got the answer here in D. That's a really higher level thinking problem. I know last year I didn't even remember it. Now that I think about it. Well, let's keep going. All right, example 3. Max is building a swimming pool in his backyard. He measures the length and the width of the pool so that opposite sides are parallel. He also measures the diagonals of the pool to make sure that he knows that they are congruent. How does he know that the measures of each corner is 90 degrees? All right. Parallelograms tell you that opposite sides are equal. Incongruent. So number 6, right? We wrote in rectangles. So that's number 6 is a quality or a property that only rectangles have. And it says that diagonals are congruent. Okay? Being parallel and being congruent for opposite sides is not enough information. All right? Diagonals had to be congruent. So that's a pretty good question there. This quadrilateral has vertices. Right, look at these vertices. Determine whether it is a rectangle by using the distance formula. So like we've said before, we're not just going to let you forget things. Distance formula, usually every year I make every single person do this. And if you don't want to do it, you'll find out you'll end up at the board in my class. So here you go. The bad news is that you have to do this 3 times. So you'd have Wx is equal to something. What other lines do I got? Well, if I went around it, I'd have xy. I'd have yz, and then finally zw. So then I go up here. All right. If I was to do wx first, all right, I see the value of -2 and -1. So -2 minus -1. All right. That's going to become a plus squared plus. Then I'd have to do 1 and 3. So 1 minus 3 squared. Alright, this is going to equal square root of -1 squared plus -2 squared. Alright, and then we're going to have 1 plus 4. 1 plus 4 is going to equal the square root of 5. So Wx is the square root of 5. Okay, pause the video. Unpause the video. If you want to write down the stuff in red real quick, I'm going to erase it. So if you haven't written it down, get some work out, do the work so you have examples. Alright, you see the eraser, pause it, write it down. Alright, next one. So now we got xy. Xy is going to equal, right, I'll start at y, 3 minus, now I got to go to x, so minus the -1 again, right? You can see that's going to be 3, double slash, chunky plus, whatever you want to do. Y2 is going to be 1 minus 3. Okay, so then I go down here, square root, 3 plus 1 is 4 squared, plus -2 squared. Okay, the reason right here that I have -2 inside the parentheses is a -2 times a -2 is a 4. And then 4 squared is actually 16. So this is going to, xy is going to equal the square root of 20. Okay, kind of the same deal here. Right? Eraser's coming. So if you need to write it down, pause it, write it down. Sweet. I'll go back to red. Now we'll go YZ. So YZ here, I got 3 minus 2. So I'll go square root 3 minus 2 squared plus. Then I'll go to the next one. 1 minus a negative 1. There's that negative 1 again. Minus a negative 1. Make a plus. Alright, YZ is going to equal 3 minus 2 is 1. 1 squared plus 1 plus 1 is 2 squared. Alright, I like what I see here. 1 squared is 1 plus 4. Square root of 1 plus 4. You got it, square root of 5. And then we want to do one last one quick. And everybody hates this problem because they do distance formula, but it's a lot of good practice. So ZW. Alright. Alright, Z is 2 minus. W is a negative 2. So minus a negative 2 squared plus Z, negative 1 minus 1 squared. Alright, ZW is equal to the square root. 2 minus a negative 2, that's going to be a plus. So I'm going to have 4 squared plus negative negative is a minus 2 squared. So that's going to be 16 plus 4, which is going to be square root of 20. That's pretty good. Technically, we only proved it's a parallelogram by doing the distance formula 4 times. If we wanted to check that it was a rectangle, we should have actually just checked that the diagonals are congruent. Okay, so I did a lot of work for nothing. So, we better do that. And if you're whining and complaining right now, that's your own fault. You should have caught my mistake. So what we're actually looking at is WY. Alright, WY, real quick, is going to be negative 2, W, and then Y is 3 squared plus Y1 is 1 minus 1 squared. Alright, WY is going to equal negative 5 squared plus 0 squared. I'm not even going to put parentheses there. Negative 5 squared is a negative times a negative is going to be a positive 25. Square root of a positive 25 is a 5. So WY is actually equal to 5. Alright, eraser's coming. I wasted my time. I'm sorry I wasted your time. But we need to do this correctly. So then WY, and then XZ. Alright, so X to Z, notice how I skipped one. So we got square root, negative 1 minus Z is 2 squared plus, now I went with negative 1, so here's X, all the way over there I gotta do 3 minus Z is negative 1 squared. Okay, this is going to equal. Alright, I'm going to have negative 3 squared plus 3 minus 1 is going to be positive 4 squared. And this is going to equal, negative 3 is 9 plus 16, which is going to equal a square root of 25, which is going to equal 5, which is actually going to equal WY. So both diagonals have a measure of 5. Alright, that's a mistake that I just made. It's a common mistake. Alright, I was just going to show opposite sides are equal because that's the easiest to do. That actually only shows it's a parallelogram. Very good. Now, diagonals, on the other hand, show you that a rectangle has to be congruent. Hopefully, lesson learned now. Right? If you get to your quiz and you tell me diagonals are equal in a parallelogram, it's wrong. Diagonals are only going to be equal in rectangles. So when you get to this problem on your test, which I know it's on your test, only check the diagonals. Alright, sorry about that. Review of 6163. So this is a parallelogram. It's actually pretty similar to the one on your test. This angle right here, I'm not going to keep it short and sweet. 2t is right here. 2t has to equal something. And if you are screaming at the top of your lungs right now, alternate interior, please quit screaming. It's distracting others. Alright? This is alternate interior. The 2t has to equal 18 degrees. Divide by 2. Divide by 2. T equals 9 degrees. Alright, then the next one. 4r, 18. So 4r has to equal 18, because those opposite sides are congruent. Divide by 4, divide by 4. R is going to equal 4.5. Alright, then the last one, S. Okay, this is a diagonal here. I don't know why, but I went with 3. Diagonals are still bisected in parallelograms, so it would have been 8s equals 7s plus 3. Subtract 7s, and 8 minus 7 is still just 1s in my book. I'm not going to write it. I'm just going to box s equals 3. Alright, then this last one. Example 6. Ooh. I didn't delete example 7. Example 7, sorry. Ignore example 6. What is the sum? Here's the key word. Interior. Interior needs to trigger your memory. N minus 2 times 180. So if it's a 16 gone here, 16 minus 2, I would say is equal to 14 times that 180 is going to be 2,520. And no, I didn't do that in my head. Okay. We're done. You are going to have a worksheet, which the sub should be able to pass out to you at this point. I want you to make sure that you show him a completed key, or your completed note sheets. Should look similar to my key with a lot of work on it. And then also, I told the sub to not make seating charts. Alright? I don't always make you guys have seating charts. However, if you got your name written down, or if you were a distraction in class, you're going to have a seating chart. I'll make sure that you are perfectly seated in the correct spot, whether it's on the corner, on the floor, like an elementary kid. If that's what it takes to discipline you, then that's what it takes. Right? Make sure you leave class with a worksheet. Right? You're able to watch this video anywhere. It's going to stay on Schoology. You can review for the quiz with it. Right? I know it got a little long there. We did the distance formula a few extra times. But, hey, it's worth it. All about learning in this environment. For those of you that don't know who I am, thanks for listening. And have a wonderful Monday. Stay classy, San Diego.